Welcome everyone. So in this video, we will work out this problem. This is volume by double integrals. We want to find the volume of the solid by subtracting the two volumes. So here's what we're looking at. The solid is enclosed by parabolic cylinders, this one, and the planes, these guys right here. So those are the surfaces. So we're going to draw our region D in the XY plane. So these are the curves we're going to be sketching in the XY plane to figure out what is the D, the domain of integration. So we know that, recall, volume is going to be the double integral over the region D of the surface f of x comma y dA. So we need to figure out what is our dA based on what is D in the XY plane. So let's go ahead and sketch those two parabolas. They're in two dimension. We know they're parabolas because we have x squares. Okay, so here's how I'm going to draw that. So here's our XY plane. And we know one of the parabola is facing up. That's this one right here. Now, before I do that, I also think it'll be best if we find the intersection of the two parabolas. We set them equal to each other. So we have 1 minus x squared is equal to x squared minus 1. So I'm trying to figure out what is the intersection. So when I draw, I know exactly how to draw that. So let's add 2x squared on both sides. So we have 2x squared, and then add 1 to both sides. We have 2, which means x is equal to plus or minus 1. So that is the x-coordinate of the intersection. So let's now draw the parabola. So one of the parabola is facing up, something like that. So this will be y equals x squared minus 1. And the other parabola is going to be facing downward. So I'm going to draw that like this. So I know they intersect at 1, negative 1. Something like this. So this is the intersection. This is negative 1, this is 1. So this is our region of integration. This is D, all of this. Now you want to decide D is best described as type 1 or type 2. And that's how you will determine what is dA in our double integral. So to me, it looks like a type 1 region because if you take a cross section that is vertical, so I draw a cross section in the region like this, I have a top and a bottom, and as you slide it throughout the region, you will have top and a bottom. So it is a type 1 region, which means D is going to be described as the set of points in R2 such that we'll have to find bound on X and then bound on Y. So Y is going to go from top function to the bottom function. So the bottom function is the parabola that's facing up. So the one in pink, that is y equals x 1 minus x squared. That's this one. So our bottom function is this one, and this is the top function. So our bound on y would be to the bottom, we said is the parabola facing up. So I'm going to a little bit more room. So we will have x squared minus 1. And the top function is the one in pink. That's 1 minus x squared. Now, what about the bound on x? Well, x is going to range from here to here. So those are the constant values, negative 1 to 1. So there you have it. That is how we're going to describe the region. And those are also our limit of integration. And we also know our dA, it's going to be dy dx because this is a type 1 region of integration. All right, so putting all of that together, we set up our volume. So we know our volume of this solid is the double integral over this region D of our function f of x comma y dA. And we just decided dA is going to be in this order, and these are the bounds right here. So I'm going to go ahead and set that up. So we will have our outer integral and inner integral. The inner integral is respect to y, so we'll have x squared minus 1. Here we have 1 minus x squared. That's the upper limit of integration. The lower limit for the bound on x is negative 1. The upper limit is 1. And here we're going to have the surface, the top and the bottom. So because we're bounded by two different surfaces, both surfaces are planes. So we need to figure out what goes here. So we'll have a z top and a z bottom. So I'm going to rewrite my f of x comma y, which is really z, the function z. We will have a z top minus a z bottom. So that's what we mean by subtracting the two volumes. Now we need to figure out which surface is on top, solve that for z, and then which surface is on the bottom, solve for z. Going back to my problem again. So here's the surfaces. We have this one and this. Both of these are planes. You want to solve them for z. Now, to know which one is on top, which one is on the bottom, you can find some points on the surface. For example, if I set, let's say, x, y equal to 0, this surface gives me z is equal to 2. For this surface, if I set also x, y equals to 0, here I will have z equals to 10. That means this one has to be on top. So this is going to be the top surface, and this will be the bottom surface. So we have a z top and a z bottom. Now, we need to solve each of these for z. So I'm going to go ahead and, for the first equation, I'm going to solve for z by moving x and y to the right-hand side. So you'll have z is equal to 2 minus x minus y. For the second one, I'll solve for z. So I will have 2x plus 2y plus 10. That's my z bottom. So as you can see, both of these are function of x comma y. So that's what our integrand eventually had. But we have a top and a bottom. You can also set this up as a triple integral, which we will discuss later. For now, let's just go ahead with the double integral. So I know my z top. My z top is this one. I know my z bottom, that's this one. So let's substitute them into our integration down here. So we will have the following setup. So we know our z top, we said that was, this was 2x plus 2y plus 10. That was equal to z, and then z bottom, we said that's going to be 2 minus x minus y. All right, and then close up the bracket, and we put in our dy dx. All right, so that is how you set this up. So what I have really replaced here, this is my z top, and here's my z bottom, meaning the top surface and the bottom surface. Subtract 2. Okay, let's clear this up. Let's distribute this out so we can simplify the integrand before proceeding with the integration. So I'm just going to rewrite this one more time. So we have 2x plus 2y plus 10 minus 2 plus x plus y, combine like terms. So you'll have 2x and an x, that's 3x, 2y and a y, that's 3y, 10 minus 2, that's 8. So that is what we're going to put in the integration. So our integral we have is -1 to 1, and then we have x squared minus 1, 1 minus x squared. Here we will have 3x plus 3y plus 8, and now we integrate respect to y and then x. All right, so looks good. Okay, now let's proceed with the inner integral. First, we're going to take care of this. We'll integrate respect to y first. Hold on to x. So we'll treat x as a constant. So we have the outer integral, hold on to that. Integrate 3x respect to y, you'll have 3xy. Integrate 3y respect to y using the power rule of integration. This is 3 over 2y squared. Integrate 8 respect to y, that's 8y. And then we're going to evaluate all of these from x squared minus 1 to 1 minus x squared. And then at the end, we integrate respect to x. Okay, so a little bit of clearing to do. So for each y we see here, we're going to substitute our upper and lower limit of integration using the fundamental theorem of calculus. So do it very carefully because it's a bit of work, which we need to do it with the good care. So I write out my outer integral, and we substitute. So we have 3x times y. I'm replacing with the upper limit of integration first. So I have 3/2 1 minus x squared, and then plus 8 times 1 minus x squared. and now minus the lower limit of integration. So now for each y, we plug in x squared minus 1. We'll have 3x times squared minus 1, and then plus 3 over 2, x squared minus 1 squared, and then plus 8 times x squared minus 1. Close the bracket, dx at the end. Okay, so let's clear this up. So we have, I'm just going to keep writing the integral so that I don't forget it. So we have some distribution to do right here. And then here we need to expand this, then distribution here, expand here, and then distribute, and then expand here. All right, so let's see what this gives us. So we have 3x minus 3x cubed for the first part. Here, if I expand this, this will give me 1 minus 2x squared plus x to the 4th, and then that gets 3/2. So this will give me positive 3 over 2, and then minus 3x squared, the 2 cancels out, and then plus 3 over 2x to the 4th. All right, now the last term, if I distribute 8, I have, okay, so when I distribute the 8 to the negative x squared, that will give me negative 8x squared. Now the next terms we will distribute and also distribute at the negative. So we got 3x cubed minus 3x cubed. 3x times negative 1, that's negative 3x times a negative, so that's positive 3x. Now here we expand this out, so x squared minus 1 squared, that'll be x to the 4th minus 2x squared plus 1, and then times the 3/2. So that'll be a minus 3, all right, so that's going to give us a minus 3/2 x to the 4th, and then negative 3x squared times a negative, so positive 3x squared, and then positive 3/2 minus 3 over 2, and then the last term we have negative 8x squared plus 8. Close the parentheses, and then we integrate later. All right, let's clear things up. So if you look at it closely, you'll see that things will start to cancel. For example, let's see, this one and this one, they cancel each other. Then 3/2 and negative 3/2. Then we have this one and this one. So they also cancel each other out. Okay, so looks like the rest of the terms are going to combine. So we will have our integrals from -1 to 1. So here I'm going to go ahead and combine 3x and 3x. That'll give me a 6x, then negative 3x cubed and negative 3x cubed. That's going to give me negative 6x cubed. Then we have negative 8x squared, negative 8x squared. That's a negative 16x squared. And lastly, 8 and 8. That's going to give us 16. All right, so this is what we're going to integrate now, respect to x. All right, not so bad. So proceeding with the integration, so we have 6x integrated respect to x, that'll be 3x squared. Integrate 6x cubed respect to x, that will be 3 over 2x to the 4th. Then the next one, we have 16x cubed over 3. And the last term, 16x. And now we're going to evaluate this from -1 to 1. And we're almost there. Okay, plug in the upper limit in place of each x. So that would give you 3 times 1 squared plus 3 over 2, 1 to the 4th, minus 16 over 3, 1 cubed, plus 16 times 1, minus the lower limit of integration. So we'll have 3 times -1 squared, plus 3 over 2, -1 to the 4th, plus, no, sorry, this term is minus 16 over 3 times -1 cubed, and plus 16 times -1. All right, so clear this up very carefully. So we will have a 3 plus 3 over 2 minus 16 over 3 plus 16. So here I'm also going to start to distribute the negative out as I expand, okay? So negative 1 squared, that's positive 1, distribute the negative, so that's a negative 3. And the negative 1 to the 4, that's also positive 1, distribute the negative, so that's negative 3 over 2. Then we have negative positive, so negative 16 over 3, and the negative 16 minus 1, that's positive 16. Okay, and then you start to see that this will cancel out. So we're finally just left with this numerical value. 16 and 16, that will be 32 minus negative 16 over 3 and negative 16 over 3. That's 2 times 16 over 3. And this will simplify to, let's see, 64 over 3. Alrighty, that is the value between the two surfaces. Okay, it took us a little while, but we got there. So I hope you enjoyed and got the same answer as me. Okay, see you next time, everyone. Thanks.